We're out of Machinery USA, out of Charlotte, North Carolina. We are a multi-billion-dollar company that sells automated turning lathes, punch presses, lasers, logistics and automation, ASRS, AGVs, kind of you name it. We're at booth 338844 if you guys want to come visit us. This presentation is going to talk briefly about automation and the typical path that job shops and or contract manufacturers or large OEMs may take in their process. I would like this to be as interactive as possible, so if you have a question, don't necessarily wait till the last bit to ask it. Just raise your hand and I'll get to you just as quickly as I can. You know, it's my interpretation. It may be different than your interpretation, so by all means, please speak up and let's have a conversation, because that's why I'm here. I'm here to teach you as much as I know and hopefully maybe learn a little bit from you guys as well, okay? So before I start, are there any questions that anybody, are you in the right spot? Yes, sir.
Will you be able to make this presentation available to us?
I believe IMTS will send it out. If not, my suggestion is drop me a business card and I'll make sure that you have it. Absolutely.
Thanks.
Anybody else to get started? All right. So, by the way, the microphone is stuck right here, so normally I would walk around and peruse the audience while I do this, but since the microphone is stuck, I'm going to sit right here, okay? So, talk about the turning buying timeline, right? So, we're going to talk specifically about turning machines in this, automatic lathes, simply because that's kind of where we are, machine tool, right? So, stage one, obviously, if you're starting off to begin with, or you're contemplating buying your first machine, you're going to buy a manual load, single spindle, horizontal lathe with tailstock. I'm getting nods, am I right? And then you go, man, why am I doing this? So the answer to the question is pretty simple. So there's advantages for buying just a single turning machine. Those advantages are simple. You can start slower. You can conserve your cash flow. If you are cash flow conservative, this is going to give you an opportunity to kind of wade in the water before you jump in feet deep, right? Obviously, it's a relatively small footprint. You can have a limited trained staff in order to do what you want to do. There's very little risk because of all the previous things we mentioned, and there's a whole lot of players in the field, right? So, guys, give me some examples. Haas, give me another one. Yell it, come on. I know you guys have turning machines, right? Raise your hand if you have a turning machine. 1, 2. Milling machines, 3. Okay. There's a lot of players. We'll talk about some of the players later on, but this is the idea, right? So that machine is roughly $70,000 if you're going to buy a brand new. Okay. So just think about this as we go through it. Disadvantages. So these are what I see as disadvantages. I would like for you guys to speak up if you think there are any other advantages or disadvantages from a single spindle. But it's a very manual process. It's really hard to grow. So I spoke to a few of you before you came in, and one of the things was you want to be nimble, right? You want to be able. So that's an advantage here, but it could also be a disadvantage, right? It's really hard to grow. So if you want to increase your business, if you want to go from, a million, 100 parts a month to 1,000,000 parts a month, having one single machine is going to be pretty difficult. You got to purchase a saw. If you don't already have one, you got to make blank somewhere. And then last but not least is the market is now a commodity. So everybody and their brother wants you to buy it. So how do you choose which one's the best one? That's for a different presentation. All right. So with that being said, to go to step 2. Well, you just realized that your business is very busy and you need a second machine. So what do? You go buy another single spindle machine with tailstock. Am I going down the path that for those of you that have turning machines, is this the normal procedure? Right, okay. So another example, this is a smart machine, okay. They make a great machine. I'm not gonna bash anybody. Everybody's machines are good. There's advantages and disadvantages for either. So let's talk about the advantages of going with a second machine. Well, you can grow as demand grows. You still are cash flow conservative, meaning that, if you're holding that money tight because you have to buy, you gotta pay for employees, you gotta buy raw stock, you gotta invest in employees, which is right now the hardest thing to do, right? Raise your hand if you're having employee issues. Yeah, every hand in this room should go up. look, I'm having employee issues, and look, I'm trying to pay them more than everybody and their brothers. I hired a kid right out of high school, $25 an hour, had to match Lowe's hardware. Can you believe it? I can believe it, right? Many players in the market, still low risk. You already have a saw, so you're already blanking off things to go on your first machine. So let's talk about some disadvantage. It's still a very manual process. Your footprint has to grow, whether you put the machine in front or beside your existing lathe. And then it's hard to gain time. So, you know, if you have a customer that you've been working with for 10 years and that customer wants a price reduction every year, how do you give them that when the process is exactly the same? Well, you can throw another machine at it, you can throw another employee at it. Your cost really remains the same, it doesn't go down, okay? So that's the transition. Again, about $70,000, so up to 140 grand. So the third step, well, now you want to add a bar feed, okay? So the bar feed allows you to start automating. So this is the first step into automation. Actually, let me back up. The automatic lathe is the first step to automation. For those of you that ever had a manual lathe, a CNC lathe is really your first step. So we're already automating the process, but now we're automating it to the point where maybe we have a little bit of room to grow, right? So, you know, bar feeds are different. You can have bar feeds, you can have bar stockers. It really depends. I put a rough number of about $50,000 just depending on the bar length, just to give you an idea. But really, let's talk about the advantages. So you really can grow as demand rises, right? So your customer says, hey, look, I need you to make 1,000 parts a week. Well, you can run a lot in the evenings now that you have a bar fed machine, and you can potentially go home, be with your kids. You still control your cash flow. You're a limited trained staff. You're already existing. You don't really have to add somebody to add, you know, a bar feed machine. Very little risk, and you've automated the first process, okay? Now, we didn't talk about this earlier, but I'd like to digress just slightly. So if you're doing a part that is op 10 only, when you have a single machine, you're gonna run all op 10, you're gonna set it to the side, you're gonna set back up, you're gonna run all op 20, or maybe you're even gonna flip the part inside, but you've got a guy or girl standing out there tending that machine, right? So this allows you to at least automate op 10 if you wanted. When you go back to op 20, you're not gonna be able to because it's already on a bar. So the disadvantages, it's a manual process still from op 10 to op 20. Significantly larger footprint depending on the bar length, right? Because you gotta put it beside your bar, beside your turning machine. So therefore, if you're running 20-foot bars, man, that's a very large footprint. Significantly footprint, so that cash flow, well, now you have to stock bars somewhere, so you have to stock, right? And then you have two inventories because you're probably still slugging for your other turning machine, and you're currently running bars for your secondary machine, okay? Any questions yet? Everybody good? Okay. All right, this is where we get really interesting. And all the guys and girls out there will tell you this is where the money starts to really roll in. So now you automate the process, okay? You're adding a third-party robot for tending. Anybody name the big one out there? Fanuc, okay? Look, they're turning a $100,000 car upside down, flipping it. If you haven't seen it, it's pretty cool. I found out they had to buy that car. They returned it to the dealer afterwards, but they had to buy it, all right? But anyway, so third-party tending. So in the picture gives you a really good example. So what is this doing? So it's taking op 10 from machine 1 and moving it to machine 2 for op 20, right? So, I mean, it's pretty positive. That's a real big step into automation. So let's talk about the advantages. Well, you automate the in-feed and now the out-feed. It isn't just the in-feed on one, you're doing the in-feed on the second machine. You're still cash flow controlled because you've bought one piece of equipment at each time, so you're growing as your cash grows. You don't have to say, hey, look, I need all this money up front, this is what I want to do. You can ramp up significantly more quickly now that you can go op 10, op 20. And there's really no additional floor space because you're putting the machine, if I back up one step, you're putting the machine between, the robot between the machines that you had already. That's where your operator normally would have stood. Now you're running a robot there instead, okay? So let's talk about disadvantages. Well, now you have to program teach points on this robot, so you have to have somebody that is a little bit more skilled with robotics and integration. There are integrators out there that will be happy to do that for you, but unfortunately for you, you either have to hire somebody or you have to outsource that process. It's really hard to be nimble, so, you know, Jack be nimble, Jack be quick. Once you have that guy in there and you're running from op 10 to op 20, if you want to change over parts, man, it's really difficult to get in there and do that. So it's hard to be nimble. If you're running millions of parts a year, millions of parts a month, it's easy. However, if you're nimble, it's difficult. All right. Maintenance of multiple machines. So most of them have maintenance contracts, and I understand that. But look, when you call up somebody and say, hey, come work on my machine, they may be there in 24 hours, they may be there next day. Unfortunately for you, you gotta kind of be on the spot, so your maintenance guy's gonna have to handle yet another machine. Lots of touch points for changeover. So if you're changing within a family of parts, going from part A to part B, that part is slightly different. You're gonna have to reteach that robot. Now, if you're switching over for a part that's not new, once you set it up the first time, it's really easy for the next time. So I'm not discarding the fact that robots are good. What I'm saying is that you have to teach multiple touch points in order to do that changeover. Added auto doors. Anybody know what auto doors are? For those of you who have robots, so in order to change your part out, you have to open the door, right? The robot physically can open it itself. I think I have a video of that. Or you can put an auto door that's fed by the IOs of the machine, and the door will open. You'll pull the part out, the door will open on the other side. What happens when the door opens? Does anybody know? What stops? The spindle, right? You're no longer making parts. It's dead time, okay? And if one of the machines are down, what happens? Well, unfortunately, that whole cell is down. You can make parts on one side of it, but you're stuck because now you only have two machines. You got a robot sitting in between it, and you don't have the ability to be nimble between them, all right? So here's a couple examples where robots can really add significant help in production. So this is a 3-cell and a 4-cell robot on a track. So I'm not telling you robots are bad, I'm just telling you that there are advantages and disadvantages, and you have to look at it based on your business to decide, is it the right machine for you? Does anybody have any setups similar to this? At least one robot, 2 machines? No robots? Robots? Anybody? And y'all need to go to the Fanic booth. They'll show you how to work. All right, so we've talked about single spindle with tailstock. So there's an MT style machine, and basically what it does is it's a spindle on one side and parallel, so it's a spindle on the other side. So you can do op 10 and op 20 within one grab, right? So it's really good for long parts. It's really good for live tool and or not live tool machining. So advantages, well, you can do those op 10, op 20 in the same machine. If you need to see one, I have one in my booth. You're more than welcome to come there and look at it. Cash flow controlled, again, you're adding one single piece at a time versus jumping all in together. And nimble is now an option because now you're running your 2 machines with your robot on one side. You've added a 3rd machine that can do op 10, op 20. But what have you done? You've progressed in the automation, right? So now you have 2 spindles in one machine versus 2 spindles in 2 separate machines. You can make a whole part without leaving the confines of where you are. Your robot's running, it's running great. You're running the parts that you've always ran, and you get to add on this other part. Okay? What's the problem with running parts that you've always ran? Well, it's hard to make extra money when you've always ran it because you had to take it at such a low price to get it. You've added your cash flow as you've come, and your customer doesn't want to take a price increase, they want to take a price decrease. Okay? Disadvantages of that, well, now you're programming yet another machine, so you've got now, 4 machines that you're programming? Hopefully you bought the same manufacturer on the first 2, that way it's only 3, but you never know. Lots of floor space is required. So if I go back to the picture, this is actually one of the smaller machines. Those machines are relatively large. I mean, if you think about a single spindle, so I've got 2 of them side by side. Maintenance on multiple machines, lots of touch points, and skilled labor is now needed. Mainly because of the software side, not necessarily because of the actual turning, but the software side to program that machine. There's lots of good software guys out there. We tend to lean you towards one versus the other, but look, Esprit to me is the cream of the crop when it comes to programming turning machines, and it takes a very skilled person in order to run that. It really does. Look, my man over here said yes, right? All right. So stage 6. Well, you guys knew this was going to happen. You got to add a bar feeder to your MT machine. All right. So now you've got a bar feeder on your single spindle. You've got a bar feed on your MT machine. Your shop's getting pretty large at this point. You've got basically 3.5, 4 machines. So what are the advantages? Well, you've now automated op 10, op 20 for that MT machine. Look, I'll preach it again, cash flow is still controlled because you're buying one machine at a time. It's kind of like growing your family, I guess, you know, having one kid at a time. I used to think twins was the best way to do it until I found out there were two bills with it. And then long runs are now really possible with these. So, you know, once you put that bar stock with the feeder on it, the nice part about it is you can set it up for op 10, op 20, go home. Now you've got two cells completely running all night. So that's good. Let's talk about the disadvantage. Well, like now you got a third location for stock. Last time you just had bars and slugs. Now you got bars, 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 and slugs, right? So you have multiples. Lots of floor spaces required, maintenance. You're now harder to be nimble because you've now hooked your MT style opposing spindle machine to a single part or a single family of parts. It's hard to be nimble for that. And for those of you who don't know, you can hand load those machines, which is great, but now you're back to the single spindle kind of idea. If you're gonna bar feed, they're limited to their core size, right? So, you know, 2.5, 3, 4 inches, that's about as max as you're gonna go. And if you're real thin, man, that's, you know, 3/8. I don't really want to go less than 3/8. So depending on what you're making, right? So, again, I love these machines. We've got 2 in our booth. I think they're great. Is it the right machine for you? As you're automating your process, it is definitely within the steps of machining. It's in the steps of turning, but you may not want to start there. All right, so let's look back at what we did. So we took the entire step, right? We're growing, we're getting great. We've automated the process. We've added a robot. We've added a different style of machine. You got to start over, right? Because as you're growing your business, what do? What's the next buy? The next buy is either to go back to the robot or go back to the single spindle. I'm here to tell you there are other options, okay? This entire presentation is about there are other options beyond the standard what you're used to, all right? So you spent a total of $610,000 to get where you are. My guess is you've paid most of it off by now, which is great because cash flow is easy. And I'm not telling you what I'm about to tell you makes sense for your first machine, but it's something to consider along the way, all right? So alternate thinking from the beginning. So does anybody know about robotic integrated gantries? Raise your hand if you do. And if you work for Mirotech, don't raise your hand because no, I'm just kidding. So what are they, right? So they're this little thing at the top. It basically, a gantry, the terminology gantry is above a machine. That's where gantry comes from. But these gantries are used for loading, unloading, gauge checking, blow off, and material movement, okay? Can your robot do all that? No, not really. It could, but while it's doing it, your machines aren't running. So I got a quick video here that I'd like to show you guys. This is a robotic gantry that is loading a slug from a feeder table, putting it to a rechuck station, going in through spindle A for op 10, a turnaround station, spindle B for op 20, and then outfeed to, it could be a conveyor, you could do it to a wash station, you could do it to a rechuck, you could even go to another machine if you wanted an op 30 or op 40. So this machine is actually in production at this part in my booth, so at the end of this, if you really want to see it firsthand, we can walk over there and I'll be happy to show it to you, but just take a look for a few minutes. There's no sound, so I'll kind of get it. So it picks it up, puts it down into a rechuck, make sure it had it correctly. So there, put it in, getting ready to put it in spindle A. Door doesn't have to open, so as soon as it moves out, it starts. This is your turnaround station, so it's putting the slug from 1 and picking the slug from 2. Going into the spindle on the right-hand side for op 10, or op 20, excuse me. Here's the finished part. And then when it picks it up, it puts a new blank in so it can continue. By the way, I'll tell you, on this side, spindle A is currently spinning. That's the major difference on these machines, and out it goes. So while you saw spindle A, spindle 1, putting a new slug in, spindle B was still running. If you remember back to the original robot that we talked about when the door had to open, like you shook your head on the auto door, the door opens, the spindle stops, right? And this one, the spindle doesn't stop. There's a there's an automatic door that opens up for the gantry to come in, and while it's moving, the other side is still running. Okay. So disadvantages. Let's talk about disadvantages of gantries. Well, they're more expensive from the start. So again, this isn't going to be your first machine, probably not your second machine, maybe third, fourth, fifth machine. Planning must take place to begin with. So if you're thinking about this machine from the beginning, you really have to think through the process of what am I going to do eventually. You must have working capital. You must have a good idea of the parts to start. You know, again, ideally it isn't your first machine, but after 2 traditional lathes, it's the only way you're going to really make money because you have to change your process. Okay? So, advantages. Well, you integrate from the system, from the builder and manufacturer, meaning that you're not adding a third-party robot. You're not adding a Fanuc or a Yaskawa or a UR robot outside your machines. You're adding an integrated gantry that's controlled on the controls from the controls of the same. So on our machine specifically, Fanuc is our controller. Fanuc runs the entire thing, both spindles, both tool sets, both turrets, and the gantry all at once. It's all within a single controlled unit. So when you have an issue with your robot, it's 1 call, not 2 calls. Okay. Many of the teach points are fixed. So if you go back to the video and think about where it was, it picked it up from a feeder table, that point's fixed. It put it in a reach up, that point's fixed. It put it in the first spindle, that point's fixed. It put it in the first turnaround station. It put it in the second turnaround station. It put it in the second spindle. All of those points are fixed. You don't have to reteach them. So when you're doing your programming, it's far easier because you already know the location. So programming it is far easier. No auto door is needed. Smaller footprint because the gantry is above the machine. You don't have to, you can literally put 2 machines side by side if you want front to front. And you don't have to take in that additional space with a third-party robot. All right. No barred feeder for 2 inventory locations, and can run it unattended for long shifts. Now, let's talk about the disadvantages, because there are some, and I want to tell you that. All right, well, actually, I skipped ahead of myself. The unseen ones. Spindle idle time is greatly reduced because the door doesn't have to open. The gantry is part of the machine, op 10, op 20. We kind of talked through all these already, but the accuracy, and most important, the safety. If you remember the robots that we showed earlier, the robots were enclosed in a cage, or there's something around them so that nobody can get in on that. Since this is part of the machine and it's running, you don't have to worry about pinch points, you don't have to worry about crashes. That's all involved in the housing of the machine, okay? But I'm gonna skip and just show you guys a couple of other videos real quick, because I think it's important for you guys to see it. So here is an auto door with a third-party robot. Door opens, spindle has to stop. It's got an A-B configuration on it, just like the gantry that I showed you on our machines. So it takes the slug out, it puts the new slug in, and it pulls back. It moved it over to op 20, as you see. That's great, right? It is, but how long did that actually take? 20, 30 seconds? Most people think that this is the stopping point when it comes to automation. So I'm gonna give you an example of our machine. So what you see in this video, just briefly, this is a twin spindle front-facing machine. So it's just like the one I showed you in the video. And this is a single spindle machine. They're sitting side by side, and the gantries talk to each other. So I'm just gonna show a real quick video of it so you can see. Picks the part up, does a reach up, puts it into the first spindle. Goes to the turnaround station, spindle's working the entire time. When the next one's done, it goes in. Look, spindle on the left is still working. Spindle on the right on the third one is still working. This one has 2 sets of gantries, but you guys get the idea, right? So while you're working, you're still working. You're not limited to the door opening and stopping. You're giving yourself the opportunity for the spindles to keep spinning, because ultimately, at the end of the day, you're looking for more parts on your dock at the end of the day, right? I mean, that's the goal. talked about the unseen advantages. So let's talk about people that offer gantry-driven machines, because we're not here necessarily to talk about Mirrortech. We're here to talk about everybody. So DMG Mori, anybody heard of them? Yeah, work for them. You used to work for them. Hey, they're great machines. They really are. I mean, I'm not going to bash anybody up there. Doosan. I guess they're not called Doosan anymore. They have a really big booth out there. I don't know if you guys have seen it. Eurotech, Fuji, Haas. Is that everybody knows Haas? Yeah. Haas is probably the single, 50% of the turning machines sold in the US are Haas. However, they don't make up for 50% of the revenue. Problem is that you have people like Motor City Spindle Repair that's all they do is repair hospitals all day. It is what it is. Mazak, another great machine company. Mirrortech, Nakamura, Akuma, they got a really big booth too, I think 100 by 150. Takamaz, Takasawa, and Tsugami. All great machines. All have a lot of pluses and a lot of minuses, right? So, a traditional horizontal, we showed that one at the beginning, so that's your single spindle with a tailstop. Now I want to talk through the terminology so you guys understand. So single spindle front facing are the type of machines that I showed you where you're going to slug. Ours all have integrated gantries, so again, if you want to see them, come to the booth. Twin spindle opposing, that's your MT style machine. So spindle on one side, spindle on the other side. Twin spindle parallel, that's the video that I showed you. Front facing, two spindles. Some of these guys, they offer only turning, some offer machining turning, some offers live tools, some don't offer live tools, some offer bar fed, non-bar fed. Really, you could even add a gantry to an existing machine. There are integrators out there that will add a gantry to your machine fixed on a rail across your machine. So I'm not telling you that you necessarily have to buy a new machine in order to get there. What I'm telling you is that there are options beside adding a third-party robot. So is this making sense to anybody? Is it? All right. So, types of CNC lathes. We talked about them briefly with traditional horizontal, twin spindle. But more importantly, let's talk about the dollars that are associated with it, because you need to understand. So a traditional horizontal, you're probably looking at 110 to 150. Now these are with gantries now. This is not non-gantry, this is with gantry. So if you thought about it originally, I think we said $70,000 for a single spindle. So this one is, just a little bit more, and it's already integrated. Single spindle front facing, that's like the machine that I showed you that we sell, 165 to 225, comes with a robot. Twin spindle opposing, again the MT style machine, they face each other, up 10, up 20, a little more expensive. Look, you can get some cheap ones for $350, you can get some very expensive ones for $650. It's kind of like buying your wife a diamond ring. They're all nice, they just are slightly different. Twin spindle parallel, they front facing each other. All right. So some offer turning only, that's strictly just a lathe. So when it comes to machining, you're not going to be able to do any machining. Tool stationary, the spindle spins, right? So some offer live tools. So everybody knows what a live tool is. Okay. For those of you who are interested, Mirrortech just came out with a brand new machine that is the only machine on the market that is a dual front-facing live tool Y-axis lathe. So you can do up to, what is it, plus or minus 60 millimeters on the face, almost 4 inches. So go take a look at it. It's a Haas, not a Haas, but a Haas. Big one. It's nice. All right. Some offer bar fed, some offer both. Again, we have a machine downstairs that has both bar feed and gantry. That way you can be as nimble as possible. If you want to run bar feeds in the evening, if you want to run gantries from a feeder table in the evening, it's your choice, right? So where does that work out? What if you have a part that's non-symmetrical? A casting. Can you run a casting through a bar feed? No, right? So having the gantry gives you the ability to start running parts other than symmetrical parts. All right. So slugging. Does everybody know the difference between bar fed and slugging? Raise your hand if that's a yes. I see some nods. So it's important to kind of go through this, right? So the difference between bar feed and slugging. So bar fed machines, obviously you're putting in raw stock and bar feed, right? What are the advantages of bar fed? So long parts, especially if there's tail stock, right? If you're holding the part, you can limit the wobble, okay? Or really, really, really short parts, because nobody wants to feed a part that's a 1/4 inch long by hand into a spindle, chuck it up and turn it. You'd much rather stick a bar in there, okay? I agree, I would too. Disadvantages, well, so you're limited to the bore diameter. I think we talked about that earlier. You know, 3/8 of an inch to maybe 3.5, 2.5, somewhere around there. There are some larger machines out there, but you're gonna pay a prettier penny for that, 6 inches. Costly cutoff tools. Anybody actually run a machine in here? Nobody? All right. Well, just so you know, the cutoff tool is the most expensive tool in your library because it takes the most force and you're always going to replace the insert, guaranteed. Non-straight bars. So ASTM obviously calls out for straightness in a bar, but you order a 20-foot bar, I believe it's 5/8 of an inch over 20 feet. So when you put the bar in your bar feeder and it's ran through your machine, the bar in the bar feeder is actually spinning. A lot of people don't realize that. So if that wobble in the back turns to the wobble into the front, you start to get a little bit of issues when it comes to making parts, especially if it's a long part. All right, edge condition. Always got to face it off to begin with. Long part-time transfer. So what I mean by that is if you're doing a parallel spindle front facing, this spindle has to come in, it's got to cut it off, it's got to pull it back, all while the spindle's not spinning. It's just unfortunate. It's the way it is, but you can automate it, so it's a good option. Lots of floor space, and you can't do op 10 on both sides. All right, is that fair for everybody? Everybody get that? Any questions here? All right. So let's talk about advantages of slugging, because this is where you can really, yes sir?
The bar feeder, the last piece remaining.
Good point.
Is that possible to machine or?
Yeah, so if you have a bar, what the question was, so when you're pushing a bar through a bar feeder, it grabs a hold of it and pushes it the rest of the way. There's I'll call it a slug. There's a portion of the bar that's left within the spindle itself. And most people throw it away. However, if you have machines for slugging, you can slug that last little piece and make potentially another part. But really, a lot of it's waste, because if you have, let's say, a long, let's call it a 20-inch part, you're gonna have 6, 8, 10 inches at the back of it that you're gonna throw away as scrap. So slugging gives you the opportunity to saw cut those to length and get engineered stock size so that you can limit how much scrap is at the bottom. So instead of losing 4, 6, 8 inches at the back, you're only losing 3/16 of an inch on a saw cut. Does that make sense to everybody? Thank you for your question. So you can chuck larger diameters in slugging. So your bar bore that we talked about, 3.5 inches, you can put an 8-inch part in a chuck, a 6-inch part in a chuck that's slugged, but you can't feed it through the bar, right? So you can do much larger parts. Saw cutting can be done offline in parallel versus in series. So while I'm running my operator, because I'm running continuously now because I have an integrated gantry, my guy could potentially be going saw cutting for the next job coming up. So you're not losing somebody. You didn't lose somebody because you put automation, but you've given somebody a reskill and repurpose so that you keep them busy, right? Spindles are constantly running. There's no cutoff downtime. That's the cutoff that we talked about when the two spindles are coming together. You can bundle cut bars very quickly. You don't have to cut a single bar at a time like you do on a cutoff. And you already own the saw because you bought it with the original turning machine back in step 1, right? So you're repurposing a machine that you already have. Questions? So disadvantages of slugging. So it's limited to the gantry capacity. So when you buy a robot or a gantry, you buy it based on how much weight and what size it can hold. So there are limitations on gantries. So you may buy a gantry that can handle 10 kilograms, but you have a part in there that's 12 kilograms. Well, now the gantry can't do it. You're back to manually loading. Okay? And you can't do long parts. So because they're front facing, you probably can do 4, 5-inch, 6-inch parts maybe. Beyond that, you're gonna struggle because you're gonna get lots of wobble. So long parts, you're strictly gonna wanna go with single or 2 parallel spindles if they're front facing. You're not gonna do that long of a part. So they have their place, they have their time, okay? Any questions on the disadvantages and advantages of slugging? This is a really hard concept for a lot of people to gather simply because they're used to bar feeding. They just don't ever remember where they started because everybody started off slugging. And when they got bar feeding, it's like they just forgot amnesia. They forgot what they started with, and then all of a sudden, they only want to bar feed. Bar feed absolutely has their advantages, guys. All right? Everybody good? We're close, don't worry. A lot of time for questions, I hope you have some. All right, so conclusion. There's lots of people out there that have lathes, lots of people out there that have automation, and understanding the automation is important, all right? They tend to follow a path. That path isn't fixed. It can be a little loose at times, but most importantly, they get stuck to what they always know. When we go back to the bar feed that we talked about a minute ago. They started off slugging, but they forgot about it. They got used to it because they think that's the best that they're gonna get. As your customers have asked for reductions in price points, you can only add so much automation before you have to change the process. Once you change the process, you can add that potential profit back to the bottom line that you've really forgotten. Planning for the future is beneficial from the start, okay? Again, I'm not telling you that you gotta start with a gantry to begin with, but you should know that it's available. You should know that there's a consideration for that versus adding a third-party robot. But let's stop right here because robots are important. If you go down to our booth downstairs, we have 2 integrated robots with our machines, but every machine we have has a gantry. And you'll ask me, well, why? Well, somebody still has to load slugs onto the feeder table. Somebody has to load parts into a machine. So rather than tending a machine, going from op 10 to op 20 or putting in parts, we use the robot. So we have a UR robot on our machine that's bin picking, like a 45-degree elbow. And it picks it, it puts it in place, the gantry picks it up, sticks it into the first spindle, sticks it into the second spindle, and then outfeeds. So it's important to realize that there are still times and places for robots. Just I want you to be thinking about it. So once you own it, repurpose it for something different, right? Still use it. So what we've done on our robots, our integrated robots, because we integrate with Fanuc, we integrate with Yaskawa and UR robots. The biggest thing for them is how we use them. We don't use them to tend our machine, but we use them to supplement the lack of employees to load the machine. Does that make sense? Obviously, we're downstairs. We have mirror talks going on daily. For those of you that are interested, we're talking about slugging versus bar feeding downstairs at 11 o'clock and 3 o'clock daily. And it will be somewhat of this, maybe a little bit more in depth to talk about when is the right time to slug versus the right time to bar feed. I touched on some of the major points because we're really talking about automation, but we have a full in-depth conversation there. And then we also have a mirror talk on single spindle and parallel spindle machines, front-facing machines with integrated gantries, which is a little bit more about kind of what we've talked about here, and talk about how that third-party robot isn't a necessity, but it's definitely something that you can add to your bottom line. So that's really all I had for you guys today. I left a little bit of time for questions. I hope you guys have some questions that I can answer. Again, I'll be happy to get this presentation to you. Do you know if they're passing out the presentations later on?
They're gonna be online.
They'll be online? Okay. But give me your card, and if not, I'll still send it to you. So can anybody have any questions, concerns, want to understand a little bit more? I can go back in the slides, go to the videos and detail anything out. Don't leave me hanging up here. Yes, ma'am.
So you mentioned that if these type of machines make it easier to have like a high mix of parts.
Yes.
How easy is it to program if you see a new part every single day and you will never see another part again?
So let's talk job shop, for example. What you're telling me is you're a job shop. You and I spoke earlier, you're insourcing some of the stuff because no one can be fluid enough to do it, right? So my guess for you is, for you using a gantry for one or 2 parts or a small run of parts, it doesn't make a whole lot of sense. It really doesn't, right? And the major reason it doesn't is because for you to program the actual loader to pick the part and put it in, it'd be faster for you if you're only making 10 just to put it in, right? Now, if there's a family of parts that you use, applications engineers, our controls engineers will be happy to, not just ours, but anybody, to help you set up that control, right? So if you have, let's say, a 2-inch diameter part, then you go to a 4-inch, and they're within a family of similar parts because you said they're one-offs, but I guess in one-offs, I would tell you that I would imagine your process, they're similar. They may be longer, they may be shorter, they may have this feature versus that feature, but they're similar in nature. If they're within a similar family of parts, it's very easy. So you can do quick changeover grips, you can do quick changeover chucks, you can do quick changeover grippers, and during the mirror talk, we do it in about 15 minutes. So it's not difficult, you just have to know how to do it. All right, does that answer your question?
Yes.
Okay. Anyone else? Yes, sir.
Do you have any data or study which shows what is the difference between operating efficiency of robot cell versus the integrated gantry?
So I personally don't have that information. I know that we have done that data in the past. We've compared, in our plant a few years ago, we had one of our twin spindle machines standing next to a robotic machine making the same part at the same time with a ticker above it. And we were running 24 hours a day, they were running 24 hours a day, and it was almost 2 to 1. Now, but it depends, right? Because it depends on the part. If the part has a very long cycle, opening the door for one single piece, it's not that big of a deal. If your cycle time is 2 minutes and it takes 30 seconds versus 10 seconds, saving that 20 seconds every cycle for 24 hours a day is huge. So it all depends on your part, right? So what we will do is, for us, we will give you a time study based on your part and what we tell you we're gonna do, and we're gonna be plus or minus 15%. But if you're already currently running automation with a robot, you're gonna compare your cycle time versus the time that we're gonna provide you. And that's really, you have to make the decision. Do you wanna take the step into integrated automation versus third party? Anyone else? Well, guys, thank you so much for coming to the presentation. I hope I did well for you. If there's any additional questions, you're more than welcome to come up and see me. Give me a card, we can start communicating. And if you want to come downstairs again, we're at booth 338844. Be here for the rest of the week. We have food and beer and wine every day from 11:30 to 3:30. All right, thank you guys.